Hey, hi, this is Shailendra here. I'm the founder at HyperTest. Thanks for joining the webinar. In the webinar today, we'll be discussing what are the new ways or what are the most efficient ways of testing microservices. Because if you are considering moving to microservices, already moved to microservices, the old ways sadly don't work. So let me share my screen. It's going to be a small 20-minute presentation where I'll take you through the approach and would love to take any questions at the end of the webinar. Thank you. Okay, so I'll share my screen. Sorry for that. I hope you're able to see my screen. Okay, so yeah, that's the topic for the webinar. So before we start there, I hope the audience here already understands the benefits that teams get when they move from monolith to microservices. But let's first discuss the quick reasons. So in most cases, when you or your team would decide to move to microservices or already moved one, the two biggest reasons I would assume would be that the size of the team that you're managing now has become larger. So you might have been a smaller team when you started your project, but now the size of the team has become a little bigger because you want to contribute, or you want to develop your project maybe at a little faster pace than what you used to, and it is becoming difficult for your team to contribute on the same code base. Second could be that, and as your application is growing, there are a lot of moving parts in your applications, becoming complex. You're adding new features. It is becoming a little difficult now for you to continue to maintain all the complexity of your application in a single code base. So it may be in the right time for you to do microservices. And the third thing, and the third reason that affects everybody, that all of us, want to develop or make new features live for your users as soon as possible. With a monolithic structure, with a large, complex, slow-moving code base, it becomes increasingly difficult for you to keep adding new changes and make those changes live to your users at a quick pace. So now, well, consider moving from monolith to microservices, or the reasons. Typically, these are the reasons. Speed, agility, control. But the core question now is that when you decide to move to microservices, testing them can become as hard as confusing as testing the monolith was if you continue to rely on the old ways. And there are simple reasons for that. Well, a microservice environment is full of these large number of small moving organisms, these small units of microservices that are completely independent. They can be deployed independently. And with these many moving parts, there are a fresh set of challenges, a fresh set of problems that arise when you're testing them. Imagine when you are using a monolith with a single large code base. If you do encounter a problem, it is very simple to roll back the entire application and then start debugging and fix it and release again. But what happens with smaller, with a more distributed code base is that the source of the problem, the source of the problem itself could be buried under any of these several microservices, but since they are all connected to each other, these problems propagate very quickly. So one of the challenges the teams face, when they are testing microservices, is that it becomes increasingly hard for them to locate the source of the error. Where did the error originate from? Because of these large number of, intercommunicating units. And well, sometimes speed could largely mean more accidents. So what is the right approach? But before we discuss that, let's take a quick digression and discuss the story of Atlassian. So usually all teams believe that the test parameter is the holy grail of testing, and it's served testing teams well for more than 2-3 decades now. Well, almost everybody's believed that this is the way to go. It's being tested, tried, from the experience of a large number of teams. But there's something that needs to fundamentally change if you use this approach to test your microservices, given that you still want to maintain the speed, the agility, and the control that came when you split your code base into microservices. You don't want to lose speed or the control, the flexibility, just because those microservices or that application full of microservices need to be tested before they're deployed. So if you're sold on the fact that speed, agility, and control need not be compromised, the traditional pyramid approach needs to change a little. So to explain that, let me take a quick story. The story is of a company called Atlassian, pretty popular, maker of the most popular softwares like Jira and others, all collaboration software. So this is a true story. This is a problem that happened, I think 3-4 years back, when and it's narrated by one of the engineering teams. So what happened was that one of the teams at Atlassian actually saw an incident reported at PagerDuty, and the problem actually was regarding the billing service. So there is a functionality or a service inside Atlassian that creates bills and invoices for customers. But it was a strange or surprising bug that happened in the application. That service was not able to create new bills or invoices for the customers. And sadly, this happened over the weekend. Well, everybody had went home, and this issue came up, and the team that was responsible for that specific service, the billing team, looked through it and understood, after debugging the problem for about 2-3 days over the weekend, must have lost a lot of sleep, is that the source of the problem was not the billing service. It was actually the user service. So there was another service inside Atlassian that the billing service talked to. So every time they created a bill or an invoice for a customer, they asked the user service what was the details of the user for which the bill was created. And the source of the problem originated from the user service. But the team went back, after they've understood why this happened, the team came back and spent about a week now trying to do a postmortem as to why did their test not catch this problem. So what kind of test did Atlassian had? Like all teams, they had end-to-end acceptance tests, but they failed to catch these problems. And the team realized that teams inside Atlassian had already begun to completely distrust these tests. They did not believe in the results of these tests. And these teams asked around the other teams and people who were responsible for maintaining or running these end-to-end tests, and realized that these tests were failing 80% of the times for reasons other than the underlying code, the environment, or the configuration. And this had made teams started distrusting the results of these end-to-end tests. So teams already knew that the end-to-end test that they had in place, or the end-to-end suite that they had in place, had tests that were failing because of the tests themselves and not the underlying code. And it had not been very cheap to build these tests. It was very, very expensive. These tests took a lot of time to run. They were very, very slow. And on top of it, they were not reliable at all. And as I said, the teams were already beginning to distrust them. So the reason, in spite of having spent enough time building and running these tests, Atlassian was not able to catch that billing issue because I think at some point in the middle, teams have realized that these tests were no good. So they had failed to cover that important user flow that would have caught this problem in billing issue, because the teams had already given up on end-to-end tests because of the inherent problems with end-to-end tests. They are very, very expensive to build, require a lot of coordination between teams, and even if you're able to achieve any degree of confidence in terms of coverage of these tests, they are very, very untargeted. They end up failing for all the reasons other than the underlying code. But Atlassian also had a unit test. And well, unit test actually strikes off all these problems that end-to-end test are. They're very targeted. They're very, very cheap. They can be built very quickly. They're very fast. They complete in 2 to 3 minutes, and they tend to be very reliable. But in this case, they were not able to catch these problems. Why did that happen? Because the engineers who were building these tests, engineers from the user service as well as the billing service, forgot to update mocks. So unit tests are built to test a specific unit, tries to mock all the downstream dependencies, but because you are writing these own tests and the mocks that come with it that, so to say, fabricate the response of the downstreams have to be updated from time to time. So in this case, for Atlassian, they were writing unit tests, but forgot to update the mocks. And because of these outdated mocks, their test ran, they passed, should have failed, and hence were not able to catch this issue. So what is the right approach? We believe the right approach happens to be these unit tests, these service level contract tests, but with the added, or with the addendum that somehow the mocks that these tests depend on should be able to update smartly. The reliance that these tests have on engineers writing these tests to update their mocks should somehow be smartly handled for these tests to be effective. But this is the best approach when you are testing microservices, to have unit tests written for each of these services and the downstream dependencies for each of these units to be mocked, but those mocks to be updated very smartly. So I'm going to take a very quick example of what I'm talking about. Imagine in a microservices world, you have a lot of these small services or units that are talking to each other. Let's take a simple example of 2 services that are talking to each other. I'm going to illustrate how this approach of having unit tests in place would have helped Atlassian catch these issues, again, with updated mocks. Now, imagine there's a cart service that talks to a catalog service. In this case, the cart service sends a request to the catalog service. And the catalog service, like a dutiful, a duty-bound downstream service, has to respond back to the service. Some response. In this case, asking for some details and comes back with some details. So cart is the consumer, the catalog is the provider. And now if this system ends up working perfectly well, anytime catalog service changes its response, the cart service would get to know. In the example of Atlassian, this relationship was between a billing and a user service. So the user service, because of which the problem occurred in the billing service, had told billing that it had updated the response to the billing service, this problem would not have occurred. So the simple way to do this is to somehow mock the responses or mock the dependencies. What does that mean? Now, if a team is writing unit tests for cart service, so is the other team who is responsible for catalog service writing test for it? In an end-to-end, in an integration scenario, or say, let's just in an integration scenario, what teams are really after is making sure that these 2 services that depend on each other, the integrations between these services, so the communication between these services are tested properly, which means that when the cart service talks to the catalog service, the cart service can depend reliably that the response it is getting back from the catalog service is the right response. And when the catalog service is requesting or sending back that response, it can it knows what is the request that the response needs to be sent back with. Now, in a classic integration environment, both these services need to be up, talking to each other real time, so that the cart and the catalog service are aware of the request and the response they need to send to each other. And that's the difficult part. That's the reason. That's the reason end-to-end tests don't work, because in that case, if you are sitting in an application, or you are in an environment where there are multiple microservices, all these services need to be up at the same time. It's a pretty big engineering challenge. The team wouldn't like it. So is there a way that service integrations or service communications can be tested without needing those services to be up all the time? The way to do that is mocking downstreams or mocking dependencies. But now that begs the question, well, that's originally what Atlassian was trying to do by trying to mock the dependencies, but well, they forgot to update the mocks. So how will that work? I think you would have understood so far that the problem happens because the downstream, here in the case catalog, which was sending back a response, in this case where the cart was expecting the response back from the catalog service, changed. But the cart service was not made aware of it if the response to the downstream was mocked. And since it was not made aware of it, the test that the cart service has written were passing all the time versus having versus getting failed and notifying the owner of the cart service that they need to now accommodate the new response. This is what it should have ideally happened. One way of doing this is with HyperTest. So HyperTest is an no-code automation tool that integrates with all the services, all the different units at the same time, and uses traffic to automatically generate unit test. And we'll probably have another webinar to explain how that works, but generally just explaining it in a few sentences, HyperTest monitors the traffic of the application. It's an SDK that sits inside the code base of that specific service, monitors the network traffic for that specific service, and uses that to automatically start building these unit tests. So the first requirement is met by automatically building these unit tests that teams need. And what HyperTest does is that when they're building these unit tests, it essentially mocks the dependency. So for the cart service, when it's building this unit test, it will mock the response of the catalog service by monitoring the response from the network. And when the tests that HyperTest has generated for the cart service are run for again, they are run with the mock of the catalog service. Now, a lot of people will ask here, how does that solve the problem? Because if the response of the catalog service changes, as I was explaining you here, how would HyperTest get to know? So in this case, what HyperTest do is that it is going to sit on both the services, and if the response of the catalog service changes, it will dutifully update the mock and let cart service know that there is a new response that is available from your downstream dependencies that will fail your existing test. And there's another way to do this, very popular approach called Pact, which essentially solves the same problem. So what teams desire here is a way in which the dependencies of their services are not only mocked, but they are reliably updated when either of the two services change their request or the response. To simplify that, for the test of cart to work again, it needs to know that the response that it had mocked from the catalog service has changed. Similarly, for this test of catalog to work, it needs to be reliably told that maybe the request that the cart service sends to catalog has changed. So the Pact is a way for both these services to keep notifying each other that the request or the response that they were dependent on have changed. In HyperTest case, this happens automatically. You don't need a broker in place. HyperTest essentially is that broker, which you don't need to tell explicitly, as it happens in the case of Pact, that the response to the request is changed. As HyperTest runs test for both the cart and the catalog service. And when it runs this test for catalog service, if it sees that the response that the catalog service sends to the cart service is changed, it will run the test for cart, fail them, and update the mock. Or maybe it will ask the owner of the catalog service if they're sure that the response that it sends to cart is changed. If they approve the change response, the mock that the cart service was dependent on changes. So this is a way in which HyperTest ensures that every service inside the microservices world is protected. The approach here is having the ability to automatically generate unit tests, which mocks the downstream dependencies or mock dependencies. But when it mocks dependencies, it ensures that if the mocks of these dependencies are changing, the responses of these dependencies are changing, the mocks are updated automatically, or without without the owner of the downstream services to go out and physically update the mocks. And the best thing about something like HyperTest, even like Pact, is that if you set up HyperTest across all your services, it produces something called as a dependency graph. So all your microservices, as I explained in the start of the webinar, are dependent on each other. And there's several such communications that keep happening real time. It's almost difficult to keep a track on. And that is one of the reasons why your applications break. In the microservice world, the root of the problem could be buried under in service number n that could propagate all the way up to any service. So if you've set HyperTest or if you've set Pact across all these services that you're testing, you can reliably test all these individual services with their respective mocks, or which are mocking the downstreams. But if the downstreams change their response, these mocks are smartly updated so that your test fail, and you're told that your service might break because the downstream has broken. Such is the case here with HyperTest. So just quickly, I'm going to wrap up this webinar by quickly telling you the example. As I was explaining in the last slide, once HyperTest is set up across all the services, if the test for catalog are run, the reason because catalog has just undergone a change, and HyperTest encounters that the tests are failing because the catalog has changed its response, it will dutifully update or notify all the services that are dependent on catalog. The cart, the checkout, or the payment services. The test for them could also be run. They'll obviously notify them of the failure. But the best thing about this is that the mocks that these services, cart, checkout, and payment, use to test their own services would be updated because the downstream's response has changed. So in summary, when you are in a microservices world, as I explained, the hardest thing about testing microservices is having the ability to test different communication between these services. And the usual approach the teams take is building end-to-end test. End-to-end tests are very difficult to write, very difficult to maintain. They do serve the purpose when they run, if they're able to run properly, that they can get you to the problem, but that needs all these services up and running at the same time. In this approach, you don't need all the services up and running. When you are changing a specific service, all that you need are tests that are written for that service, but you should be in a position to run tests for that service in a way that you are also able to test how that service is dependent on all the other services. This, in the microservice world, is the true and the most efficient way of testing inter-service integrations without needing to build expansive end-to-end tests, or without needing all these services to be up in the test environment at the same time. You can run unit tests in which mocks are updated smartly using the approach that Hypertest provides, or Pact, to run local tests for your services and verify very quickly whether your services are working fine or not. This is what I wanted to explain in this webinar, that in the modern world of microservices, the best way to test your application is using unit test with smartly updating mocks that can verify integration between your services. In the next webinar, we'll tell you a little about how that works in case of Hypertest, which not only eliminates the need to write these tests by monitoring your application at the network level, but also smartly updates them, as and when the responses of your downstreams changing. So thanks for joining the webinar. I hope you found this useful, and please stay tuned for more such webinars and podcasts to be done by the Hypertest team. I'm pretty sure if you are already in the microservices world or you're planning to move to microservices world, you'll find this approach of testing your microservices very useful. Thanks a lot.